Good morning, everyone. Hope everyone's staying healthy. We are continuing our notes today. These will be the last notes for Chapter 8. Next week, in our 2 days, one day will be a review and a catch-up, and the next day will be a Chapter 8 assessment, probably on my math lab again. So, I'll tell you what page we're on this. Well, not what page, sorry. We have blank notes posted on Schoology as always, so if you want to open those up and you can take notes along with me. But if we're in class, what I'd start with is having you solve this triangle. And what I'm giving you here, 3 lowercase letters, means I'm giving you 3 sides. And what I want you to see is, first of all, there's no right triangle. It doesn't say there's any kind of right triangle. So you can't use any trig, sine, cosine, or tangent ratios, and you can't use any Pythagorean theorem. So if you tried law of sines, this is what you'd get. You get sine of A, you don't know angle A, over 6. You get sine of angle B over 8. And what you can see is we have a problem. We have 2 missing angles. Nothing we can do. Even if you went on with C, it'd be sine of angle C over side C. So there's a problem. I'm missing, whether I use these 2 fractions, or whether I use these 2 fractions, or the outside fractions, I'm missing too much information. I'm missing 2 angles I can't solve. So the rule is this, as we go through these problems for the review and for the assessment. If you have a right triangle, do the SOHCAHTOA, do the Pythagorean theorem. Then, if it's a non-right triangle, try law of sines. If you're missing too much, if you don't have enough information, if you're missing too many angles, then you got to go to your third option, which is law of cosines. And these are formulas. You'll have these, right, for the assessment, for the review, even for the final exam. These are on your formula sheet. So you don't have to memorize them. You just have to know them. And I say down here, use these, and try law of sines first, because law of sines is a little bit easier. These formulas are a little bit more complicated. There's just more going on. I wouldn't say they're more complicated. You just have more things to plug in. So try law of cosines if you can't use law of sines. And here's the trick, though. This is pretty important. Once you start with law of cosines, stay with it. Don't go back and flip-flop to law of sines. What might happen is if you don't do things in the right order, you might accidentally walk back into an ambiguous case in law of sines. So, real simple. The general rule is when you start with law of cosines, stick with law of cosines. Okay? So, show you a quick example of how this works. Let's actually solve this triangle now. All right? It doesn't matter because I don't have any of the angles, right? I have side A, side B, and side C. It doesn't matter which of the angles I solve for first. So, and actually this one's not asking me to find all the angles. It's just saying find the smallest. So if you guys remember from Geo, right, this is angle B, or angle A, angle B, angle C. If this is side A is 6, side B is 8, and side C is 5, the smallest angle will always be across from the smallest side. That's a property of triangles you learned back in Geo. So this is basically asking me to find angle C. So let's set it up. So basically I'm looking at this guy here, right? This top formula. All right, I'm going to plug all the letters in where they go. So it should look like this. I get 5 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of C. So like I said, this is there's just more stuff to plug in. I wouldn't say this formula is more complicated than law of sines. There's just more to plug in. But again, you get them. So you just got to decide which of the 3 you're using and put things in the right spot. So now let's start cleaning. There is one trick that happens here. So let me show you. You get 36 plus 64. Now the 2, the 6, and the 8 you can multiply together, get negative 96 cosine of C. All right? Now, watch out. These next few steps is what I worry about. So first of all, order of operations, I can add those 2 together, right? The 36 and the 64 to get 100. Minus 96 cosine of C. This is where the mistake happens. You are not allowed to subtract 96 from 100. That 96 is being multiplied by the cosine of C. So that's the number one mistake I see with law of cosines. You can't subtract those two numbers. What you can do, though, is subtract the 100 over to the other side. So I'll show you what I'm doing there. I'm doing minus 100 to both sides. That is what is legal. Equals negative 96 cosine of C. Now, if you divide both sides by negative 96, you get 75 over 96 equals cosine of C, right? Cosine inverse both sides. And this is now what you saw a lot of law of sines, except don't sine inverse both sides, cosine inverse both sides, and you should get a C angle of about 38.62 degrees. And that's how you do law of cosines. That's finding an angle. Now, if this was a problem where you had to find the whole triangle, what you'd do, you'd set up another equation. You could find either angle A or angle B. It doesn't matter. And then once you have two, but use law of cosines. Don't jump back into law of sines. So you do another law of cosines equation, finding either angle A or angle B. And once you have the two angles, then you can find the third by subtracting them from 180. You'll never have to use law of cosines more than twice in a problem. So that's why I say that's why I said if you start with law of cosines, stick with law of cosines. All right. Okay. Next problem. Let's look at an application of law of cosines. So this one says on a softball field, the adjacent bases are 60 feet apart. The distance from the center of the pitching mound to the tip of the home plate is 43. So let's pause right there. That's telling me that the 43 feet are right here. From the pitcher mound to home, 43 feet. Now, I like this problem because a lot of people assume that the pitcher's mound is smack dab in the middle of the diamond. It's actually not. It's 43 feet from the home plate. And we want to find the distance from the center of the pitching mound to first base. So basically, we want to find what this distance is here. Write that. Okay, we're looking for x. So here's what you can't assume. That this angle right here is not 90, right? It doesn't say that pitcher's mound's in the middle of the diamond. So that we can't use SOHCAHTOA or Pythagorean theorem or anything like that. So we do know this though. The bases are 60 feet apart. So we know this side here is 60 feet. And we do know something else, and that's what these hints are giving you. The diamond here is made up of 4 right angles, okay? So this bottom angle by home place is a right angle, and the diagonals of the square bisect those angles. So if you bisect 90 degrees down here, you end up getting 45 degrees. Now don't stress out about these hints. You don't have to know all your facts about parallelograms and stuff. Any hints I'll give to you. So anything you need to make sure you know how to set up this picture, okay? So there's the setup, and what I'm trying to find is x. I know that this angle down here, there's my 45, and that's the setup, my little triangle. So a lot of times when I set these up, I like to kind of take the triangle out of the diagram and just redraw it, like I did there. That picture is the same as that, and now I've just given some letters to it so I can see better what's going on. So what we're trying to find here is side A, right? We called it X on the previous page. Let's call it A, just so it's easier to plug things into the formula. So I'm using the last one here, right? Because A squared's on the left side by itself. So I get A squared equals, I'll write it out for the first one, B squared plus C squared minus 2BC cosine of A. So A squared equals 60 squared plus 43 squared minus 2 times 60 times 43 times the cosine of 45 degrees. Now, 45 degrees. Now this one is a little bit easier. So finding a side using law of cosines is easier. Really all you're doing is you're typing this right side in the equation in your calculator, just how you see it. There's really no tricks. Be careful with parentheses, I guess, and stuff. Once you find it, you're going to square root it to get A all by itself. So type in the whole right side in, square rooting it, you should see about 42.43 feet on your calculator. And that's the distance between them. All right? Now listen, one thing to notice, on the Chapter 8 assessment next week, you're not going to know what, when you finally set this problem up, you're not going to know what to use, law of sines, law of cosines. You should know not to use SOHCAHTOA or Pythagorean theorem because you don't see a right triangle. So I would have tried law of sines first. Nothing would have worked, right? You don't have any other angles here to go with the 43 or the 60. You don't have side A across, so law of sines would be impossible. That's your hint, and that's how you know to go try law of cosines. Okay, so that's a good application of law of cosines. The last thing we need to talk about is area of triangles, okay? So there's a bunch of formulas here. Again, you get all of these. This section is not about memorizing these formulas. It's about knowing how to use them. So the easiest one, the one you've seen the most, is area equals 1/2 base times height. That's easiest when you have a right triangle. Reason that's easiest with the right triangles because, you know, this is your base and this is your height, right? So I would save that one for right triangles. Basically, any other triangle, I wouldn't use that formula. So if you see a non-right triangle, which is called an oblique triangle, there's 3 of these formulas. Area equals 1/2 BC sine of A. So again, a pretty basic formula. Here's all you got to remember. In the formula, you need the 2 sides and the angle in between. If you have the 2 sides and the angle in between, you can use this formula. And there's 3 versions of it, right? So again, you got an angle and you get the 2 sides. You get the 2 sides and you get the angle in between. So that's all you have to look for to use this formula, okay? If you have 2 sides and an angle in between those 2 sides, you can use these formulas. It's basically a side, angle, side, if you remember that from trig, or from geo. Side, angle, side, you're using this formula, okay? Last formula is called Aron's formula. It's a little strange. I don't know if you've seen this one before, but the formula is this. Lowercase a, lowercase b, lowercase c are the sides. So the hint to use this one is when you only have the sides of a triangle. If we go back to this one, that oblique triangle formula, I have 2 sides and the angle in between. So that's how I know when to use that. If you have no angles and you just have all 3 sides, use Aron's formula. Okay, so that's what the lowercase a, lowercase b, and lowercase c stand for. The S in the formula is called the semi-perimeter, and it's just the perimeter divided by 2. So you got a little formula here. You really don't even need the formula. It's just find the perimeter of the triangle and divide it by 2. Okay? So again, not memorizing these formulas, just knowing how and when to use them is all you got to do. So I think I get 2 problems here really quickly just to show you how these 2 things work. So again, a little geo flashback here. Don't worry about the hints. I'd give them to you, or I'd make the picture a little bit easier to draw. But it's saying the area of a rectangular, it's saying find the area of a rectangular hexagon inscribed in the unit circle. Okay, so a few hints here is that the radius is 1. So here, let's draw a few things in here. If I draw some diameters in here, just to start making some triangles, right? And in class, I'd give you a few minutes. You'd have talked to teammates. Every year, I get a few students that get this problem right. So if we draw that, I got some radii. I got a radius there, and I got a radius there, right? That distance is from the center to the edge there is 1, and from the center to the edge there is 1. So in this chapter, you're looking for triangles, right, all the time to find anything. Missing sides, missing angles, solve problems. Okay, so those are the radii. And in the circle, the central angles all add up to 360. So the central angles are these angles here, right? If they all add up to 360, and there's 6 of them, then I know that this one there is 60, right? 360 divided by 6. I know that each of these little central angles are 60. I'm only going to label the one down there so that I can deal with it. By finding one triangle, because these are all 6 triangles are the same, I can just find the area of one triangle, multiply by 6. So I'm going to focus on this area of that triangle. If I rewrite it down here, like I said before, I like to kind of sometimes take the triangles out of the diagram to see it better. I know it's like that. Now you have options. You could use Aron's formula. You could use some of your trig, law of sines, law of cosines, and find this 3rd side and use that other Aron's. But like I said, we have the 2 sides and the angle in between them. So I'm using the oblique triangle formula, which is 1/2. I get one of the sides times another of the sides times the sine of 60 degrees. And that's it. That's your formula. So now that's the area of one triangle, okay? Now if I want to find the area of the hexagon, which is a 6-sided figure, which is made up of 6 triangles, I'm just going to take that area of the triangle and multiply it by 6. So it's going to be 1/2 sine of 60, right? The 1 times 1 out front doesn't really do anything. So straight to the calculator, take that area of the triangle, multiply it by 6. That gives you the area of the regular hexagon, which is approximately, if you go to the calculator and type it in, you should get approximately 2.60 units squared. Remember, area, the units are always squared, so whatever that is in inches or feet be squared. All right? That is using that oblique triangle area formula. Okay, I'm not going to show you an example with 1/2 base times height. Again, save that for right triangles, and you think you're going to be fine with it. Let me show you an example. Let me show you this example really quickly. So it says the adjacent sides of the parallelogram are 12.5 and 8. So let's just call this 12.5 centimeters. Let's call this 8 centimeters. The measure of the longest diagonal is 14 centimeters. So you have 2 diagonals here. You got one in here. That's not the longest one. It's pretty obvious just from looking from it. And you got this guy in here. That is the longest. So that's 14 centimeters. And it says find the area of the parallelogram. Okay, so the game plan here, just like before, I have identical triangles here. It's congruent triangles. This one and the one below it are the same, right? They cut the parallelogram in half, kind of on a diagonal there. So I have all 3 sides of that red triangle, so I'm going to use Aaron's formula. Here's how it works. You got to find that S first. That S is the perimeter divided by 2. So you just add up all the sides, 8 plus 12.5 plus 14, divide it all by 2, and you get an S of 17.25, right? So then the area of the triangle, following that big formula, is 17.25. That's S. And then you have 3 parentheses here. Each one is the S minus a side. Because you're multiplying it, it doesn't matter in what order you go. I'll just follow the formula. It goes A, B, C. Well, I guess we'd even label our sides. I'll just go in the order of this sides. I have an S, and then 17.25. Move this over just a little bit. Last one, 17.25 minus 14. Okay, so that's it. It's S, S minus a side, S minus a side, S minus a side. You type it all into your calculator. Don't forget to do a square root. You could find the number underneath first and then square root it. It's kind of up to you. But the angle of the triangle would be approximately 49.63 centimeters squared. Be careful. That's not the answer to the question. The question is, what is the area of the whole parallelogram? So then you just got to double that. So the area of the parallelogram is approximately 99.26 centimeters squared. All right. So that's a good example of Aaron's formula. Back here was a good example of the oblique triangle area formula. And that's it for Chapter 8. Today we looked at law of cosines and some area. Your homework is going to be this 8.3/8.4. So give it a shot. Join the office hour today from noon to 1 if you have any questions, you just want to chat. Next week, like I said, I think the Bronco Day is going to be Tuesday, Thursday next week. So Tuesday will be a review catch-up day, and then Thursday we'll have the assessment that you're going to do for Chapter 8 that will go in as a quiz test grade. So, guys, I hope you have a great weekend. Have a great Easter if that's what you celebrate. Keep washing those hands and stay healthy. And keep emailing me with any questions. But the office hour is definitely more productive. You can get a lot more questions answered.